So Kafka and the Linux operating system. So let's start. So to give you a short introduction about myself, and I'm a senior consultant for trainer for Kafka, IBM and IB system administration. But in this training, we're going to purely concentrate on Kafka only, which is a high-end distributed messaging system. And I have given so many corporate trainings like DRDO, BlackRock, Ingram, Atas, CBS, Fidelity Investments, like this. In my professional experience, I have having more than 8 years of experience in Kafka, MQ, and IIB. So even Kubernetes also I have experience. And in my career, I have worked for insurance projects, investments projects, banking projects, and retail projects. So this is something about myself. Before explaining about Kafka, let me explain you something. For example, there is a source system and there is a target system. So here the business need is very simple. The source system has to send some data, some messages, some information to target system. So as we have one source system and one target system, so it looks like very simple, right? So source system can directly connect to the target system and it can send a message. So as one source, one target looks very simple, very straightforward. When you have more source systems and more target systems, and each and every source system has to connect to each and every target system, and all these are communicate to each other. Like 4 source systems are here and 4 target systems are here, and each and every system has to connect to each other. So source 1 should connect to all the target systems. Source 2 should connect to all the target systems. Source 3, all the targets. Source 4, all the targets. Now it looks like very, very complicated, right? So when we have just 8 systems, things becoming very complicated. Just imagine if you have thousands and millions of systems in your real-time use case, how complicated it would be, right? So it's very, very difficult, almost impossible to establish a communication among thousands and millions of systems. So to simplify this, to mimic this, so let me explain about what is the problem when we have more source systems and when we have target systems. So let's see what are the problems. So the first thing is, if you have 4 source systems and 6 target systems, you need to have 24 integrations you have to develop. So 4 into 6, yeah, total 24, right? So 24 integrations you have to write. And each and every integration comes with a difficulties around in terms of protocol, in terms of data format, in terms of data schema and evaluation. Like when you are designing a custom solution for each and every integration, you have to fix all these problems in real time. Like the source and target system, in terms of protocol, they should be good. In terms of data format, they should be accepting. In terms of data schema and evaluation, they should be having a proper shape. Yes, they're going to accept that particular schema evaluation, right? So for 24 integration, fixing these things would be very difficult. Now, when you have thousands and millions of systems, so when you want to design each and every solution for each and every integration for your 1,000 systems, just imagine you have to sit your lifetime and you have to fix them, which is almost impossible, right? And each and every source system will have an increased load from the connection. And when you are designing a custom solution to fix all these kind of problems, each and every source system again will be having an increased load, which will ultimately impact the performance of the communication between source and target system. So to mimic the solution, Apache Kafka came into picture. So if you see this diagram, in this diagram, there is a centralized Apache Kafka messaging system where all your source systems and all your target system, they connect to your Apache Kafka system. So the thing is, the Kafka concept is pretty simple, pretty straightforward. If source 2 wants to connect to target 1, so source 2 can connect to directly Apache Kafka, and target system, target 1, it can directly connect to Apache Kafka. Now Kafka will take the responsibility of establishing a communication between source and target. So whatever the protocol you do, whatever the data format, whatever the schema, that entire thing will be handled by Apache Kafka. You just put into Apache Kafka, now Kafka will take the responsibility. So target system also will connect to Kafka. Now Kafka will take the responsibility of establishing communication from source 2 to target 1. Now let's assume source 4 wants to connect to target 3. So it's very straightforward. The source system connects to Apache Kafka, and now from Apache Kafka, so the target system will connect to Kafka and it will consume the messages so that the communication will be happening between source 4 and target 3. So in Apache Kafka, there is a small concept of topic. So what this topic will do is, this topic will hold the real data that is being published by source system. So for example, in source 2 and target 1 case, source 2 will connect to Apache Kafka, and in Apache Kafka it will connect to the particular topic. So, and it will publish the message to this topic. And to the same topic, this target 1 will also connect and it will consume the messages. So this topic in a Kafka, that is the mediator between your producer, which is the source system, and your consumer, which is the target system. So like this, you can, from Kafka perspective, you just have to create a topic, and that particular topic will manage the communication between your source system and target system. Now there is no protocol you need to check. There is no code you have to develop, nothing. You just connect here and then put your message. And now Kafka will take the responsibility and to store that particular message. And after that, the target system will connect to the same topic and then it will complete the message. So what is this topic? Yes, we are going to discuss in the technical introduction part. So here we can say Apache Kafka is a router for your messaging system. So each and every system will connect to this router, and this router will distribute the message. Hey, you want to this message? Yes, take this. Hey, you want this message? Yes, take this. So that's what the role of Kafka. Now got a clarity what is Apache Kafka, and any question here? So now let's talk about something about Kafka. Now we have a picture, we have a clarity. Okay, what is the purpose of Kafka? Now let's talk what is a Kafka. So Kafka is a powerful messaging system mainly to decouple the data streams and the systems. So the thing is, as you see in the previous picture, there is no direct communication between your source and target systems. So the communication is happening via Apache Kafka. So the thing is here, the source system and target system, they are not coupled each other. Coupled means there is a direct communication, but here there is no direct communication. It's a decoupling. So we are decoupling the source and target system. It means there is no need of direct communication between source and target. So Kafka allows source system and target system to communicate in publish subscribe mechanism. So in Kafka, applications can communicate to each other through publish subscribe mechanism only. So the sender application, the sender system, the source system can publish the message to Kafka, and the target system, which is a consuming application, they can subscribe that particular message from Kafka. So it means source system publish the message to Kafka, and the target system who are waiting for that particular message in that particular topic, they can consume it. Now let's talk about what are the advantages of Kafka. So Kafka is created by LinkedIn. So initially, I hope you know what is LinkedIn. So LinkedIn is the company behind the concept of Kafka, but after that, LinkedIn has make it open source. So right now, there is a company called Confluent, which is a major vendor for Kafka. So in Confluent, you have both open source Kafka and then enterprise Kafka. So the open source Confluent Kafka is called Confluent Community Edition, where you can download the code from Confluent website for free, and you can use it in your real-time system. Even for production cluster also, you can use that Confluent Community Edition. Or if you need the support, you can purchase a Confluent Enterprise Kafka version so that you will be having the support from the Confluent. Like whatever the critical issues we face, you just open a ticket to them so that they can solve the issue on behalf of you. So when coming to the advantages, Kafka is a distributed, resilient, and fault-tolerant architecture. Now let's see one by one. What is meant by distributed? What is meant by resilient? And what is meant by fault-tolerance? So distributed means data is distributed in more than one system. So the beauty of Kafka is not a single system. Kafka is a cluster, which means it's a combination of more than one system. So whenever any publisher publishes the message to Kafka, it will be distributed based on topic replication factor. So what is topic replication factor? Yes, we are going to discuss in the technical introduction. So the thing is, let's assume for that particular topic, I have replication factor of 3, and Kafka cluster is having 10 systems as a single cluster. Now, as your topic is having replication factor 3, your data will be distributed in 3 systems. If your topic having replication factor 5, then out of 10 systems, your message will be distributed in 5 systems, so that you will be having 5 copies of same message, so that if one system goes down, that's fine. Still, 4 systems are available to serve your application. Although if 4 systems gone down, still there would be no impact for your application, because the replication factor is 5. It means 5 copies are there. 4 systems are down. Still one system is available. One message is still available. One copy is still available. So consumer can consume from there. So that's what the highly distributed. Now, second thing is resilient. Resilient means capability of recovering in a quick manner from unexpected failures. For example, if some failure is happening in Kafka, so in the back end, Kafka has some healing capability. So it can recover the error itself. So that's what the resilient feature is. When you start technically working, you can understand this resilience feature, how it is going to work, especially when we build multi-node Kafka cluster setup. There you can feel this. Now, fault tolerance. Fault tolerance means if one system goes down, other system is still available to serve the application. So as we already discussed in the distributed setup, the advantage with the distributing of the message in more than one system is to provide the fault tolerance architecture. Fault tolerance means if one is down, that's fine. Another one is still available to make your job done. So that's what fault tolerance. As Kafka is a cluster, always, although one system is down, of course, second system is there to serve your application. So the main thing is the application people, they can feel a less downtime. They never feel, hey, there is a down. Can you fix this? So no, they won't get such kind of fail. So that's called the fault tolerance. So Kafka is horizontally scalable. It means you can scale to hundreds of brokers. So for example, in Kafka cluster, it's a combination of more than one system, right? So a computer is called broker. Broker means it's a server where Kafka is installed. So for example, now I have built a single node Kafka cluster where only one broker is there. So tomorrow, if my business is expanded, my profit is expanded, my applications are expanded, then I can scale out my Kafka machines, my brokers. I can scale to up to 3 node Kafka cluster. I can scale up to 10 node Kafka cluster. I can scale up to 100 node Kafka cluster. I can scale up to 1000 node Kafka cluster also. Depends on your business demand. And you can scale millions of messages per second. So the beauty of Kafka is, although millions of messages are getting transported via Kafka, still you don't see that much performance issues in Kafka. It can be easily scalable. So if you have enough brokers in your Kafka cluster, it can support millions of messages per second. So it's a high performance. So Kafka will be really having highly performance because it is a highly distributed platforms. So there are enough systems to handle your topic. The only one thing you have to architect your Kafka is you should have enough systems to handle the topic. That's it. So the performance won't be a bottleneck in Kafka. So right now Kafka is used by 2000 plus teams. So more than 35% of Fortune 500 companies are using Kafka for their messaging systems. If you see Airbnb, LinkedIn, Netflix, Uber, Walmart, all these companies are using Kafka. And I have read an article recently, this Uber company, it is transporting 7 trillion messages per day across the globe. So 7 trillion means it's really huge. So per day in 24 hours of time, they are generating 7 trillion messages and they're successfully processing those messages. Now let's see some use cases of Kafka. So Kafka is a powerful messaging system and it can do an activity tracking. So activity tracking in the sense, for example, let's assume I have decided to purchase a mobile and I have opened a site called either Flipkart or Amazon, right? So for example, I have opened Flipkart and I searched for mobiles. I searched for 2-3 mobiles and I closed my website. I have not purchased, but I just look for this. So next day, when I again switch on my laptop, when I again open Flipkart website, so I have not done anything, But at the right side of the application or left side or top or down, they will pop up some offers. Hey, this mobile is having this much offer. This company is providing this much offer on this credit card. So they will show some offer if there exists. So although you have not searched for anything for the second time, still Flipkart will show like that. Now the thing is, how Flipkart know why Flipkart is showing only the mobiles for you? Because previously it has tracked your activity. So it has thinking that application is thinking that okay, you may be trying to purchase some mobile. So what the Flipkart application does was it has done some research. It has generated you some offers which are there. So the thing is, if you like the offer, maybe you purchase that mobile so that their business can happen. So on that intention, they are tracking your activity. Now the second advantage is gather metrics from different locations. So for example, we have Google Maps, right? So for example, if I go to any mall or if I go to somewhere, next day when I woke up, the Google Maps will ask me, hey, yesterday I visited this place. Can you please provide your feedback? How this place, what are the facilities are there? So they will gather, so they will ask that information. So how does the Google Maps know that you visited that location yesterday? Like for example, if I go to any temple also, so it will tell, hey, you visited this temple yesterday, so please provide your feedback, how the temple looked like. So they are gathering the information. So how they can gather? Because when you visited there, your Google Map, they gathered your location. Okay, you visited this place. Fine, let's take in feedback. So that they will put the data into their database, into their application, so that if any user see the review of that particular location, they can get some information, right? They can get some feedback, right? So, so Kafka can be used for that use case also. Now, application logs gathering. So, for example, there are so many applications in the real time. For example, if you want to see the logs of that particular application, if you directly log into the server and if you can see, it is very difficult to understand because to log into the server, to open the file, you need some technical knowledge, right? At least some technical knowledge. And also, that is not that much user friendly. But when you from Kafka, you can integrate Kafka with ELK. So I'm not sure if we heard about ELK or not. So ELK is a beautiful interface where the developers, the end user, they can see the logs. So it is very user friendly, very graphical user, with zero technical knowledge. So Kafka can gather that information and due to ELK, so that from ELK stack, that ELK people, they can see, okay, my application log is like this. Okay, this is the error. They can easily identify it. They no need to have any technical knowledge for that. This is another use case with Kafka. So it's a stream processing. So Kafka is always a stream processing. Like for example, you can send a stream of messages. So millions of messages as a one stream. That's all. Kafka will support that. And it's a decoupling of system dependencies. So this one we have already seen. The source system and target system, they need not to connect directly with each other. And it can integrate with Spark, Flink, Storm, Hadoop, and many other big data technologies. So Kafka is best fit in the big data. So you can gather so much of data, and systems can analyze the data and they can take the business decisions. Now let's see some background of Kafka. So what are the history and what are the versions of Kafka? So Kafka is developed in Java and Scala languages. So when we want to install Kafka also, first of all, we must make sure Java should be installed in the system, because without Java, the Kafka CLI, the Kafka binaries, they are not going to work. So Kafka is officially launched in January 2011. Now there are various versions of Kafka like Kafka 0, Kafka 1, Kafka 2, like this. So right now Kafka 2.8.0 is the stable release. And 2.8.1 is released in 19th April 2021. So I think it's not 2.8 now. I believe it's 2.9. So the latest version is 2.8.0 only. And previous 2.8.0, it was 2.7.1, which was launched in May 10, 2015. So 2.8.0, this is launched in April 19, 2021. Here I want to tell you one thing. So the thing is, in Kafka, we have two kind of, we have various kinds of Kafka. Like we have Apache Kafka, Confluent Kafka. So Apache Kafka versions are like this. Now when come to Confluent Kafka, so Apache Kafka is maintained by Apache company. Confluent Kafka is maintained by Confluent company. But the difference between Apache Kafka and Confluent Kafka is literally nothing. Both are same. Even Confluent also developed their Kafka based on Apache code only. Even when you download Confluent Kafka code, when you open the configuration file, you can see licensed from Apache software. You will see that line because Confluent just inherited that Apache foundation, that Apache Kafka code, and they added their own features. The only one thing is some differences will be there, like in terms of schema registry is there in Confluent Kafka, but schema registry is not there in Apache Kafka. So such kind of differences that they are there. But the command interface, that everything is same. Absolutely, there is no difference between Apache Kafka and Confluent Kafka. If you know Apache Kafka, it means you can definitely work on Confluent Kafka also. If you know Confluent Kafka, it means you can definitely work on Apache Kafka also. But right now, these days, Confluent is the major vendor for Kafka. Now let's talk about the roles of a Kafka admin. So what does a Kafka administrator has to do in his day-to-day activities? Number one, Kafka installations, upgradations, and configurations. Number two, topics creation, modification, configurations, and deletion. So what is this topic, how to create them? Yes, we are going to see that when we start the technical things. And Kafka broker restart, Zookeeper restart. So Zookeeper is one of the important aspect in Kafka. Like without Zookeeper, there is no Kafka. If you want to manage your Kafka cluster, the Kafka cluster internally managed by Zookeeper only. Right. So Zookeeper has a very crucial role. So in the technical introduction part, I am going to explain you what is meant by a Zookeeper. So we need to set authorizations for Kafka clients. For example, when we enable security for my Kafka cluster, only authorized people can connect to my Kafka. The anonymous user, they cannot connect. So if you want to put that functionality, you have to set ACLs, which stands for access control list for particular client. Hey, this user can connect to this topic and he can do this kind of performance. So that kind of authorization we can set with the help of ACLs. So verifying the logs such as Kafka logs and Zookeeper logs, and verifying the topics configurations. So each and every topic is having its own configuration, and based on the configuration, that particular topic is going to behave, like in terms of retention period, in terms of max message bytes, in terms of minimum mincing replica. Like each and every application can connect to their respective topics, right? And we have to design, we have to configure the topic based on their application requirement. So that we are going to discuss in the advanced topic configuration. So these are one of the major aspects of a Kafka admin. Now let me show you the course content, what we are going to discuss in Kafka. So in order to learn Kafka, the prerequisite is going to be you should have a good knowledge on the Linux operating system, because this Kafka we are going to install on the Linux operating system. So if you have the basic knowledge and good understanding of Linux operating system, that would be highly recommended. So here I'm not saying you want to become a Linux expert. No, I'm not saying that, but you should have minimum knowledge on the Linux operating system. And now a basic knowledge how a messaging product works. Now let's come to the modules, the course content. Here total we are going to cover the Kafka course in 10 modules. So out of 10 modules, the first module is Introduction to Kafka, we just completed. Now the second thing is Kafka components, like what is a broker in Kafka, what is Zookeeper, what are topics, what is a partition, what is replication factor, producer, consumer, everything we are going to discuss in the technical part. Now here comes the Kafka in-depth technical, Kafka single node installation. We'll take one Linux server. In that one Linux server, we are going to install Kafka. And how to do that? That's what we are going to see in module number 3. Now Kafka command line interface. So in this Kafka command line interface, the full-fledged Kafka administration work is going to start, like how to create a topic, how to produce a message, how to consume the messages, what is consumer groups, based on consumer groups, how does producer and consuming is going to work. So that's what we're going to see. Now advanced topic configuration. Like we just discussed that every topic should have its own configuration based on business requirement, based on application requirement. So how can we change the configurations and what are the configurations which are needed in the real time? So that's what I'm going to see in terms of retention time, in terms of message bytes, in terms of log cleanup policies, which is log cleanup delete and log cleanup compassion, and then minimum instant replica. All these are the configurations of a topic. Now module 6, from here, the production environment Kafka starts. Like in a production, if you want to install, if you want to do a Kafka setup for a production kind of case, then the single node Kafka is not at all is going to use. So single node Kafka for development and test cases, yes, we can go with this. But for the production, for the real-time case, always go with the multi-node Kafka cluster. Here we are going to take 3 Linux servers and we are going to put them in a proper Kafka cluster. So where there it is having 2 parts. Number 1, Zookeeper quorum setup, and part 2 is going to be broker cluster setup. And coming to module 7, which is a client server architecture. In real world, how does a real application can connect to Kafka? What are the things we have to, what are the changes we have to make in terms of Kafka side and in terms of client side? So that's what we're going to discuss in module 7. Now the Kafka performance. So what are the factors that are going to impact the performance of Kafka in the real world? So that's what we're going to see. Now Kafka GUI tools. So the thing is, this Kafka GUI tools is a time saver for you in the real world. Every time when you want to see the topic, you no need to log into Kafka server, you no need to execute the CLI Kafka topics list command. No, you just open your GUI tool. It could be either Conductor or Offset Explorer. Like there are many tools for Kafka. Like we have Zoo Navigator, we have Yahoo Kafka Manager. But here I'm going to explain the real-time standards, which is a Conductor and then Offset Explorer. So Conductor is purely for administrative perspective. Offset Explorer that will be used by the developers. If they want to see the topics, every time they no need to ask admin, hey admin, please give me the list of the topics. No, it's not like that. They can just simply use Offset Explorer. They can simply connect to Kafka. They can say, okay, these are the topics in my Kafka, and each and every topic is having this much message, these many messages, and these messages are occupying this much size. So they can observe with the help of Offset Explorer. But for kind of any changes, any kind of administrative task, they can reach us because admin task can be managed by Kafka admin only. And final and important thing, which is Kafka security. So here we are going to discuss about Kafka SSL security, a 3-layer of SSL security, which includes encryption, then layer 2 authentication, then finally layer 3 authorization. So this is what we are going to see. Like we'll take a full-fledged non-secure Kafka cluster and we will turn it to a full-fledged, fully secured Kafka cluster. So that's what we are going to see here. So these are the modules which we are going to cover.